Assalamualaikum warahmatullahi wabarakatuh. Today my group gonna present about Huffman coding, the lossless data compression algorithm. My name is Farhana and my group consists of two people, myself and my Sarah. Nowadays, the amount of data that is generated, sent and stored has grown more than ever. The sharing and storage of data is essential as data volumes are rapidly increasing. Data compression reduces file size without losing data, saving storage space, and increasing transfer speeds. So in this study, we compare two lossless compression methods, which is the Huffman coding itself, which creates optimal prefix codes based on symbol frequency, and package merge, which use a dynamic programming approach to impose a maximum code length. Both algorithms aim to produce minimal binary codes but excel in different applications. So, uh, we're going straight to Huffman coding. Huffman coding is a prefix code, as I mentioned before, using the symbols in a data set and how often they occur. The codes given to input characters are called prefix code, which means that the code for one character is not the start or the code for any other character. Two major parts in Huffman coding, which is build a Huffman tree from input characters and traverse the Huffman tree and assign codes to characters. So how the algorithm process? There's four important parts. First is initialization. It starts with a forest of n single nodes, three, one for each symbol. Each node contains a symbol and its corresponding frequency. Second is priority queue construction. In this part, it inserts all nodes into a min priority queue, typically implemented using a min heap, where the priority is determined by the frequency. Third is tree construction, which extract the two nodes with the lowest frequencies, create a new internal node with these two nodes as children. The frequency of new node is the sum of the frequencies of its children. And that is insert new node back into the priority queue. And the last part is code generation. And once the tree is complete, assign binary codes to each symbol by traversing the tree. Assign 0 for a left, the most left edge, and 1 for a right edge. The code for a symbol is the sequence of bits along the path from the root to its corresponding leaf. Moving on to the time complexity and auxiliary space. For tree breeding, it uses a min priority queue to merge nodes with two low frequency. For each insertion, the time complexity is big O log n node, and the total merge is n minus 1, making the overall operation is big O n log n. And the auxiliary space is a big O n for storing three nodes and the queue. This produces an optimal prefix code with minimal average code word length. And next is for the encoding process, the time complexity is the time complexity for building code table is big O n, and for encoding message is a big O L in single pass, which is constant per character. And for space complexity, the auxiliary space is constant, big O1. Output space is proportional to encode message length. Lastly, for the decoding process, the time complexity for decoding is big OL or one step per bit, and space complexity for the decoding process is constant, which is big O1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Maisara binti Abdul Aziz, and now I'm going to explain about package merge algorithm. So, firstly, this algorithm it is originally developed by Hirschberg and Larmor, where it is mainly to solve the coin collector problem, and then it developed to specifically design for length limited prefix codes and where it is ideal for system with fixed code word lengths such as Bluetooth or even 5G connection. So next, we move on to the main concepts or main steps in performing the package merge algorithm. So the first thing first that this algorithm will do is it merge the packages. So in this process, the symbols like the character or any letter will be paired up starting from the smallest frequencies or weight and combined into new packages at high levels until the maximum code length is reached. And then after building all the levels, the algorithm will go backward to choose the best packages and assigns each symbol or each character just now a code word length based on the level it appears in. And then after that, it will perform the canonical code. So in this process, where it assign the actual binary codes for each code word length in ascending order to make the encoding and decoding more easier and more memory efficient. So in this project, we want to compare between Huffman coding and package merge algorithm to see which algorithm has the best performance in compressing the data. So in this project, we use five different instances or five different size of data set where we generate random characters and we choose from very small size of data set until very large data set. So we have 10 kilobyte, 100 kilobyte, 1 megabyte, 10 megabyte, and 100 megabyte. So and the metrics that we use to measure the performance, we want to see the compression time, how many seconds that the algorithm takes to complete the compression, and then we want to see the original size and the compressed size to compare, and then total compressed bits. And how many unique symbols that the variable generate, and then mixed code word length that suitable for this algorithm. So next, we want to see the comparison between the Huffman coding and package merge algorithm. So first, we want to see in terms of the use cases. So for use case of Huffman coding, it is usually we see in everyday file formats such as zip file, PNG, and general file compression. So this we can see when we download the compressed folder or save images with small file sizes, and it will also use in many programs that need to reduce file size quickly. For package merge algorithm, it is used in a special situation, and it can be found in JPEG SR, which it is a newer image format, and we can find it in embedded system like tiny computers in smart devices, and we also use it in the real-time protocols or real-time communications such as Bluetooth that need the important data to get sent quickly and fit in small spaces. Next, we want to see the comparison in terms of execution time. So it is proved in the past studies that Huffman coding is more faster on large data sets. So this is basically because the algorithm follows the greedy method where it just pick the smallest weight first to create the tree and generate codes. On the other hand, package merge is slightly slower, we can see, because it has additional stuff that do in the background. So it doesn't just look at the frequencies, but also need to merge and group the symbols to make sure that the codes it creates doesn't go over a certain length, which is very useful in systems with limits. Next, we want to see the compression type for both algorithms. So both algorithms are lossless, which means that there is no information is removed when we compress and decompress the data. And the original file and the final file will be exactly the same, just like zipping a folder and then unzipping it. And next, we want to look at the time and space complexity for both algorithms. So for Huffman coding, the time it takes is z- um, big O and log n, which means that if the number of symbol increases, the time grows a bit faster. But it is still efficient, and the space it needs is big O n, which means it grows linearly with the number of symbols. And for package merge algorithm, the complexity is big O and L, where N is the number of symbols and L is the maximum allowed code length that we assign. So if we set a limit on how long the codes can be, the algorithm works around that limit only. So what we can conclude from this project is that the Huffman coding is a fast and popular choice for general compression like zip file or image files. And for package merge is more useful in situations where we need to control the length of the code words, like in real-time systems or even memory limited devices. So it's actually depends on where and how we want to use it. So that's all from us. Thank you.